So basically, doing a deep dive into alpha in an hour is ambitious. So what we're going to do is focus on disconnected. And I'm going to spend the next hour, and I believe it's an hour and a quarter that I have, going through what we've done in disconnected, going through sort of what's happening behind the scenes so that you understand what's happening. Because I think understanding how we've approached the problem of implementing disconnected solutions is going to help you as developers understanding what you can do and what realistically you can't do, basically. So in order to do this, what I'm going to do is sort of start out by actually showing an application running here on my iPod Touch. So this is a disconnected application. It happens to be wrapped in a PhoneGap shell, but it doesn't have to be. It could have been a pure HTML5 application. And the back end over here is a Zebra host server somewhere in Iowa, or I don't know. Clive, where are your servers? In Dallas, Texas. Okay, so basically, so here we have a disconnected application. You can see that currently I'm looking at data from the USA. And if I tap on a row over there, we're going to bring up the detail view where I can go and make an edit. So let's go over there, and we'll make an edit. We'll change that person's name to Snyder's, hit the done, and then hit the save button. So now what you can see, if you can everyone see that there? That the row there for Great Lakes food stores has a little orange icon on it, indicating that this is an edited row, but this row has not yet been synchronized with the server. So now I'm going to go to the next row over there and change that person's name. I'll make an edit to that person's name and hit the done button, and then again hit the save button. So now basically you can see now we've got two records that have been edited. Now obviously if I were to go into airplane mode right now to remove my connection, the picture on the screen would disappear. So that's not a good idea. So instead, what I'm going to do is actually close the app down completely and then restart it. So here I go on my phone, double click over there, and I'm going to go there and kill the app. So now we've killed that app, and now I'm going to go back and reload it. So go back there, and we're reloading our app now. And when the app comes up, what you can see there are the two rows that were previously unsynchronized are still there. So what that is showing is that even though the app has relaunched from scratch, all of the unsynchronized data is still there waiting to be synchronized. So now if I tap the button in the top right-hand corner over there, at this point now we're making an AJAX callback to the server, and we're doing our synchronization. So when I tapped that synchronize button there, we did an AJAX callback to the Zebra host server in Dallas, and we synchronized those two records over there. So next what I'm going to do is show what would happen if, when I hit that synchronize button, somebody else had made an edit in the meantime and we had created a write conflict. So looking at my screen right now, what I'm seeing over here behind the screen is a grid component that's going against that same data at Zebra host. So let me go here and refresh this grid by hitting the search button over there. And now what I'm going to do is, currently you can see that the record on the screen for Great Lakes has Howard Snyder in it, which is what the phone will always also have in it. So I'm going to go to that record and change it to, say, AA over there, and then synchronize that record. So now I've saved that data back on the server. So on the server now, that person's name has AA at the end of it. So now when I come back over here, and then you can see my screen over here, I'm going to go over there to this Howard Snyder, and I'm going to type in over here, go there, and type in, say, CC, and hit this done button, hit save. So now there's my unsynchronized data over there. And now when I go ahead and hit the synchronize button, you can see now there's a little red icon underneath that row there. So that indicates to the user that the record that he just tried to synchronize did not synchronize successfully. There was an error. So if I tap on the row, you can see there, and can everyone see that clearly there? That the contact name there shows in red, and it's telling me that there was a write conflict, that basically this record could not be synchronized successfully. So I'm going to go now and where it says there, it says tap to resolve, and you can see what comes up now is the conflict resolution. So who here has used source control systems in the past? So all of you who've used source control systems are familiar with the fact that in a source control system, when you do a submit and there's a conflict, the typical way in which conflict resolution gets done in a source control system is you need to choose the winner. You get to choose use my change or use their change. But of course, in making the decision about whether you want to use my change or their change, you want to actually see what your change was and what their change was, because in actual fact, who knows, maybe you like their change better. So here we have it, the exact same thing. So we've copied the paradigm of source control systems, and here you can see that your choices are use mine, which is my change, I changed it to Howard Snyder CV, or use theirs, which was Howard Snyder with the two A's at the end. So now I can choose which of the two to use. Now, in this case, there was a write conflict only on a single field, but there could have been write conflicts on multiple fields. And if there had been write conflicts on multiple fields, instead of this drop-down menu here having two choices, which is use mine and use theirs, which is letting me resolve the conflict on one field right now, the drop-down menu would have had four choices, which is use mine for this field, use theirs for this field, or use mine for all fields, and use mine or use theirs for all fields. So I'm going to go ahead now, and if I were to pick Howard Snyder SV, which is my choice, then of course the row would still be dirty because my change hasn't yet been pushed to the server. On the other hand, if I were to choose use theirs, then this row would no longer be dirty because we would have pulled the data from the server. We already know what the server has, and we would have updated the row. So I'm going to go ahead here and choose use mine, and now hit done. Sorry. Okay, so we lost me. Okay, so let me just go back here. Oh, so this, unfortunately, with our T-Mobile connection here is suspect, so we keep losing it. So let me just go here and okay, so it looks like somebody else has turned on a connection which is killing this here. Okay, someone else I think has turned on a connection, and it's.
You need, I can take this and put it there if you want.
You know what? I'm basically done. I think I'm done with. Yeah. Oh my God! Can you go in the corner for a little bit?
There's what are those guns hats on?
No. It's not working, but it, okay.
Just put this on. Plug that in, and there we go. Give it a few seconds. Let's see.
Do I need to?
No, you don't have to do anything. No, you don't have to do anything. It's okay. Anyway. You're on. You're on the right, and the left is coming up. It's up. They're both up.
Okay, so basically what's happened there is I said, so everyone can see that now, we're back over there. So you can see that the row is still marked as orange, it's dirty now, but the red mark has gone away. The write conflict is no longer there, and now I can submit my change a second time to the server, and I'll go ahead and click it now, and if we have see, I think I've lost my connection to the server now, so that's why. So it doesn't really matter though. So I've lost my connection to the server, so I can't synchronize. But basically the point is now that after choosing in the right conflict resolution, use mine, the row now can now be synchronized successfully with the server. So now, at this point now, what I'm going to do is switch over to Alpha and show how this app was built, basically. So we're going to start from scratch. We're going to start from a completely empty UX component and then go through the process of yeah, there we go. And then go through the process of building that app from scratch. And as we do that, I'm going to basically talk about sort of the different places in the UX component where you as the developer have control on the process, where you can inject your code in the different events that fire, go through some of the different events that do fire, because what we've tried to do is give you exquisite control on the entire process so that you can really customize the process. But before I actually start with the hands-on demo of how we built it, what I want to do is talk a little bit about the concept behind the way that we've done disconnected data here. So let's start out by talking about how an app works when you can assume a connection is there all the time. So in a normal web app, when you assume connection all the time, basically you do queries, you go get data, you display the data on the screen, on the form, you know, in the browser, and then the user starts making edits to the data, and then the user presses the submit button. When the user presses the submit button, an AJAX callback takes place to the server, data validation takes place. If the data validation all passes, then the record gets committed. If the record gets successfully committed, you basically report back to the user that there was no problem. Maybe you don't report anything back to the user other than turn the, say, the submit button from hot back to disabled. So that's what happens when you've got a connection. So if you don't have a connection, basically you've got really one of two choices in terms of the way you can architect an application. The one approach that you could take, which is an approach that I think complicates the solution, but is certainly the approach that many other vendors who are trying to offer disconnected solutions take, is you have on your mobile device a separate database. You have basically maybe SQLite or Pouch or Couch or something like that, and you re-architect your application so that instead of your application reading and writing directly to the server by making callbacks to the server, your application architecture is changed, and your application now starts reading and writing data to the local on-device database. And at that point, when you're just reading and writing to the local on-device database, there's no way for you to ever know, was there a server error, because you're not talking to the server, you're talking to a local database, or was there a write conflict, because again, you're not talking to the real database, you're just talking to an on-device database. And then in a separate process, this on-device database that you've got, you know, maybe this Couch database running on your phone or your Pouch database, in a totally separate process, that database is synchronizing with the server database. And if there are errors, if there are any types of synchronization errors, the database on your mobile device knows about it, but your application doesn't. So now you've got to go write a whole layer of code in your application to query the on-device database and say, were there any conflicts? How do I show the conflicts? So our decision was not to use that approach because we felt that that approach was too complicated to use and was too invasive into the design process that you already have. So the approach that we took was, look, if you have a connection and you do a submit, you get your errors back and you display them to the user resolves the errors, he tries to submit again, he corrects the errors, etc. But if you don't have a connection, then you can't submit to the database immediately, but what you can do is cache all of the edits that you've made. And in fact, that's what we do. We cache all of the edits. So you can go and you can make edits to as many rows as you want. You can enter new rows. You can delete rows. But all of the changes that you make are simply being cached locally in local storage. So that's why you saw when I exit the application, when I killed the application and I restarted it, everything came back where I left off, basically. Yeah.
May I ask one quick
Sure.
question, please. With that disconnected, am I also able to change the sort order? For
Yes.
example, if my list is
Right.
all the things that need to be done are at the top, and
Yeah.
once they are marked done, they go
Okay.
to the bottom?
What I didn't show, but I'll show it on the screen over here. So the question was, I'm disconnected. In other words, I have my data on my device now, and maybe I've pulled down, let's say, 3,000 rows of data. But now the user needs to basically do, you can't expect the user to scroll manually through 3,000 rows looking for the record of interest. Can you do local searches? And so the answer is yes. Basically, what I didn't show, but I'll show it when I run the same component on the desktop, is that what I built into this little sample app was a search button and a local filter button. So when you add a search part to a list with a detail view, you can specify whether the search is a server-side search, which means go back to the server and fetch new data, which you'd now like to bring down and keep in your disconnected list, or is it a client-side search, which means search through the existing data that's on the device and filter that down. So basically, the search feature that's built into the list supports both client-side searching and server-side and server-side searching. Okay.
My question was about sorting.
Same thing, basically. Basically, the list control supports sorting and client-side sorting and client-side filtering, server-side sorting and server-side filtering. So basically, that's a trivial problem. So sort of getting back to the basic design philosophy that we have is that all of the edits are cached. And the edits are, that cache basically of edits is stored in local storage. So that means that when I was demoing the app and I made a couple of edits to a bunch of rows, and then I closed the application down and then reopened it, you saw that basically all of the rows that I had edited were still there and they were still reflected as uncommitted because that data had all been stored in local storage, basically. This was all of my uncommitted data. And because there was uncommitted data at this point, I'm not able to go back to the server to go fetch new data, because if I did that, I would be blowing away uncommitted data. So the model that we have is basically delay server updates by caching them all. And then when you have a connection, you hit the synchronize button, and it's as though you were synchronizing each record one at a time manually, accepting that it all happens in a batch job, and then the errors get reported back to you by indicating which rows have errors, and then you can tap on the row, and then you can see the error as if you had just submitted the record in real time. So the user experience in working with a disconnected application is identical to the user experience when working with a connected application. So having gone through sort of that somewhat lengthy description of what's going on behind the scenes, what I'm going to do now is sort of go back into the UX Builder and start from scratch on how to build this application. So I'm going to switch back now to Windows, and I'm going to just exit the UX Builder and start from scratch. So I'm going to go here and create a new UX component and go over to controls. So it should be clear by now that when you build a disconnected application, the central sort of building block of a disconnected application is a list control. So, list controls now have a concept of an associated detail view and also an associated search part. So if any of you have been building grid components, those concepts should be incredibly familiar, basically. The fact that a grid component typically has an associated detail view and an associated search part. So we've basically introduced those two same concepts to the list control. And the basic pattern that we envisage when building a disconnected application is that you have an application that might be going against, say, a large database of potentially millions or tens of millions of rows of data. As much as you'd like to bring all of your 10 million rows of data around with you on your phone, you have to recognize that that's not practical. You have to bring a subset of the data down onto the phone. So that the basic idea is that when you build a mobile application using the list control, you're going to always add a search part that is going to let the user select the subset of the data that they want to bring down with them onto the phone. And that subset has to be a reasonable size. So what I'm going to be showing you is how you can actually add events into the list control to ensure that the user doesn't enter search criteria that are unreasonable. So for example, if the user basically, before he leaves the office in the morning to go out onto the road, and he enters search criteria that says retrieve all customers in the United States, and that returns 100,000 rows, that's too big a payload. You need to tell the user, no, look, please be reasonable. Enter search criteria that retrieve a more reasonable subset of the data. So we're going to go through and talk about all that. So let's start out now, and we're in a brand new UX component right now, and we need to now create a list control that is bound to a SQL database that has a detail view, that has a search part, and that has all of the synchronization buttons. So if I were to go there and sort of do that by hand, that's sort of a fair amount of setup. It certainly beats coding by hand, but it's still a fair amount of setup. So what I'm going to do now is go over to the list control here, choose the list control. And instead of building the list, just adding the list control and then configuring it, I'm going to go here to the Genie. So I'll go now to my Quick Start Genie and say, I'm going to build a list control that goes against some SQL data. So I'll choose Northwind over there. And now I can go and choose my table name. So I'll choose the customers table. And then I can choose the fields that I'd like to have available to me. So I'm going to just, for the interests of time here, just choose a few fields. So I'll just go with city and say country. And then I'm going to basically say that, that this list has a detail view, and that the fields that I'm going to show in the detail view are the same fields that I've got in my query. So I don't have to. I could choose fewer fields if I wanted to. So there's my detail view. The detail view is editable. Then what I'm going to do over here, but now obviously in a real app you wouldn't do this, I'm going to turn on debugging information. And I'm going to do that because I want to show you what's happening behind the scenes in the list when we start working with this disconnected data over there. Then I'm going to go here and say there is a search part, and that I can define different types of search parts. So if you're familiar with the grid, you can either basically define a search part where you create individual fields, like I'd like to search in the city field, the state field, the country field. Or you can create what we call a keyword search, where you just have a single search field, and then behind the scenes we search in whatever fields you specify you'd like to search in. So here again, I'm going to just choose a single keyword search control. And I'm going to say that when the user does the search, I'd like to just search in all of these fields. So there's my keyword search over there. And then I'm going to go here, this is important now, and I'm going to say delay populate till active search. So this is how you implement this paradigm that I discussed earlier, which is that the user of this mobile app, before they go offline, before they leave the office where they have their Wi-Fi connection, will enter search criteria to bring down to their mobile device a subset of the data that they want to have available to them while they're disconnected. We call that the records of interest, basically. So we want to basically not populate the list at all until the user has defined their search criteria. And then finally, I'm going to turn on disconnected. So what this does over here is I'm going to say that all of the edits and the list data itself should be persisted in local storage, so that all of the edits that the user makes while they're disconnected before they synchronized are not lost if the application terminates, or the phone loses power, or the phone gets turned off, or something like that. So I've gone through all the steps of the Genie right now, and now I'm going to go ahead here and click the OK button, and if all goes well, the Genie is going to generate a whole bunch of controls. So if you look here, you'll see that the Genie has just generated standard UX controls. So you can see here's all of my buttons that represent my detailed view over here. Here are the placeholders where I'm going to put my debugging information. Now you can obviously turn those off in a production application, but when you're developing, it's useful to have this. And here are my buttons that are going to do all of the different actions, like save the detailed view edits back to the list. If I go look behind the scenes, I can see that, for example, the save button is executing some JavaScript there. Now, can everyone see that? Because I've increased the font size from yesterday. So you can see now that we're just simply calling a method of the list called update list from UX controls. So that just got written for me automatically. And then you can see here's my synchronize button, and that code got written automatically. This is just simply saying save list edits for list 1, and then do it for all rows. So what this is actually showing is that when I synchronize, I can actually synchronize all of the data that has been edited, or I can choose to synchronize an individual row at a time, which is useful. There may be use cases where you've got a lot of edits that have been made, and you'd like to just point to a single row and say, synchronize this row. So let's just go ahead there and then hit the save button. Then we can see that the search button, basically we've automatically filled in the code here. We're executing the search list button, and we've got the mode of the search here to auto. So the different modes that a search can have are auto, client-side, or server-side. What auto means is if there is no unsynchronized data in the list, then when the user does a search, go back to the server and do the search on the server. However, if there are unsynchronized edits on the mobile device, you don't want to go back to the server because you'll blow away your existing data. So auto says if there are, auto makes a decision whether to do a client-side or server-side search automatically. So let's go ahead now and then go ahead, and then I'm going to just save this, and I'll just call it, say, Demo 1. And so now we're going to go ahead now, and we're going to switch over to Working Preview and look at our component. So now what we see is in the top left-hand corner, we can see our search part. We see our list underneath that, and then to the right of that, we see our detail view fields. Can anyone tell me why I'm not seeing any rows of data in my list? Yeah.
It's a delay.
Okay, thank you. Good. So now I'm going to go over here to my list, and I'm going to go here and type in, say, USA, and do a search. So now what happens is we go back to the server now, and we fetch data that is going to be available to us while I'm disconnected. So now what I'm going to do is go back to design mode and go back to working preview, and all of a sudden there's data there. Why is data there right now? It's cached, exactly. We specified that this list control caches its data in local storage, and since we've already done our search now, when we did the search, we went back to the server, we fetched the data, and we put the data into local storage. So the data is all cached now. So now when I run this component a second time, all of that data is there. So now when I go here, for example, let's go to this row and make an edit. So I'll go there and make an edit and hit the save button. And so now what you can see is there's the row that's gotten dirty. And because I turned debugging on, what I'm seeing over here is the JSON data that is in the list. So if we look here at this JSON data, we can see there is all of these fields over here represent the current state of the row. But most importantly here, you can see that there's an object here called old data, which represents the previous state of the row. So we've captured now in this list the current data in the row and also the previous data in the row. And when I hit the synchronize button to synchronize this data with the server, we're going to be submitting to the server both the current state of the row and also its previous state. And that is how we are able to determine if there's been a write conflict. So we automatically do all of that for you. And you can see there's other information in the list here that is telling me, for example, is this a new row? No. Is it dirty? Yes, etc. But so these are system fields that are part of this row, and this information is all there. It's in the list. You can actually read it yourself using methods that the list control supports, etc. So I'm going to go ahead here and hit, yeah.
How do you know what the primary key is of the data that you're getting back?
That's part of the definition. So okay, so let's go back now to this list and walk through basically how this list was actually set up. So I'm going to go here, sorry, and then click over there. So first of all, you can see that we specified that the return value of this list is primary key. And then, so let's actually go through some of the properties here. So here, this is just a standard list control setup. We specified a list that's going against a SQL database, and there's my query. Now the list, in this case, the data source was SQL, but the data source could also oftentimes have been custom, which is what you would use if you're going against, say, a web service or some custom data source. Just Brett, what time does this session end? Sorry, at 10:15. Okay, great. Okay. So so now then you can see that in list properties, there's two new properties over here. One that says has detail view, and one that says has search part. So when those two buttons get checked, you can see these two new panes open up in the list builder. So if we go to the detail view here, the detail view basically has a property here called table properties, and this is where you define all of the properties about the table that you're synchronizing to. But it's called it basically here I'm showing a single table. But it's much richer than this, because this list control that I'm defining right now was based on a select statement that drew data from a single table. So it was just select and a bunch of fields from customer. But it could just as easily have been, for example, select a bunch of fields from the customer table, which was joined, say, with the customer address table, which was in turn joined with some other table, etc. So my select statement could have been pulling data from 5 or 6 or 10 different tables. And in that case, this dialog over here, instead of showing a single table over here, would show all of the tables that were in my select statement. And then for each of those tables that was in my select statement, I define all of the properties that are necessary for me that give me the information that I'm going to need at runtime to make the commits to the data. So the point that I want to make, though, is that what I've showed you when we turned that debug information on, and I showed you the JSON that in blue that was stored, that JSON is what gets submitted to the server. So when you hit that synchronize button, what gets sent back to the server is this tiny little JSON package that represents the changes that have been made while you were disconnected. But having this JSON package is all well and good. What are you going to do with it? And so Alpha takes care of everything when you're going against the SQL backends. So Alpha is taking that JSON package of changes and generating all of the necessary SQL behind the scenes to turn that JSON package of changes into actionable SQL statements. And so we'll show that. So let's go back now over here. And I'll step out of this temporarily. I'm going to come back into that dialog now and go through it in some more detail a little bit later. But I'm going to go back now to working preview. And you can see now that everything is there as I left off, because we're persisting to local storage. We've made a change over there. And now I'm going to go ahead and actually let's make a change to another field as well. Go ahead and hit save. And now I'm going to hit the synchronize button. Now what you can see over here is because I have debugging turned on, I can go there and say synchronize, and it's telling me basically what happened. But more interestingly, it's showing me over here really what happened behind the scenes. So it's showing me that we did an update, So when we submitted that JSON package, that change package back to the server, the alpha server, the synchronization handler on the alpha server went and it computed the SQL from the change list. So you can see here we've basically gone and we've made an edit to the city field, and then here's our primary key over there, etc. So, so all of the data that is necessary to synchronize the records is part of the list definition. We know which field is the primary key. We also know, if we go back to the list itself, we also know which fields are being checked for write conflicts and which ones you don't care about write conflicts on. So for example, if I go back now to my field list over here and scroll down to detailed view properties, you can see that every field here in the list, I can specify things like check for write conflict. So by default, check for write conflict is turned on every field, but there's certain fields where you say, look, I don't care, basically. I'm not going to interrupt the user's workflow with reporting a rule here. I'm going to just simply say that last edit wins, and then I don't care about checking for write conflicts. So you have control at the individual field level about whether you care about a write conflict or you don't care about a write conflict. So, yeah.
If I make a second change to the same field,
Yeah.
in the disconnected mode, does it just overwrite that data?
Exactly. Basically, whatever change you make.
So I can't create my own write conflict by doing the
No, no, you can't. Basically, the only way to create a write conflict is if somebody else commits a change to the same record, the same field, not the same record, the same field in the same record that you're trying to edit. So if you edit, say, the first name field and commit, and somebody else edits the last name field and commits, since they both edited different fields, there's no write conflict over there. Okay? Yeah.
I have a question on wait.
You lost your chance.
What will happen if the row on the server has been deleted?
Basically, that's not a problem, because what will happen then is you won't get a write conflict, you'll get what's called a database server error. In other words, this is an error. So when you think about what happens when you commit a record, the first thing that you do is you look for client-side rules. And if there's a client-side rule validation, then you can't even commit the data, the change, back to the list. So once you've passed the client-side validation rule, the next phase that you're on to are server-side validation rules. So server-side validation rules are defined over here. So you go to any field. Let's just close this out here. You go to any field over here, for example, there, and you can go and define validation rules. So these are server-side validation rules. So when you submit data, when you submit data, the presumption is that you've already passed all the client-side rules because you wouldn't be able to submit in the first place. Then the first thing we do is we check for server-side validation rules. If there's a validation rule, then we immediately report back, we send an error back in the packet that gets returned that there's a validation rule. If there's no server-side validation rule, then we actually try to do the SQL action. So the SQL action may succeed or it may fail. It may fail for one of two reasons. It may fail because there's a write conflict, in which case we'll report back a write conflict, or it might fail for some other reason that is related to the database. For example, maybe you tried to put 20 characters into a field that was defined to only support 10 characters, or it might fail because you tried to update a record that is no longer there because it's been deleted. Either of those two are the same situation. It's a server-side database error, and that information will be reported back to the user. So for example, if I were to go here and then go, for example, to say this record over there, Anchorage, and start typing junk in. Okay, so now I'm typing in a lot of junk, hit the save button, and now go ahead and hit the synchronize button. You can see now that what happened is on the server, the database, Alpha didn't know that there was a problem because I didn't define a rule that said the maximum length of this field was 20 characters. So alpha then passed this all the way through to the server, and the database rejected the update. And there you can see we've reported the update. Now you can see that in this case we only tried to synchronize one row. But if I were to go off the row and then come back to it, there's the error. So if I had made edits to 30 rows and those errors basically all came back, the data gets sent back and it's part of the list now. So I can navigate from row to row to row in the list and see the errors that were there.
Show the JSON. Show it in the JSON.
Okay, so I don't have a button here that turns the JSON on. I could do that. I could easily go back to here. Let's add a new button. So I'll say toggle buttons. And then I'll go down to this section over here called predefined. So in the defined controls here, I can just go here and choose list control detail view buttons. So these are all of, this is like a little genie for putting buttons onto the detail view. And I'm going to just say show data in list for debugging information over there. So I'll go ahead and do that. And now what Dan is saying is that I should go here. And now if I go here and say show data in list over there, you can see there that there's somewhere over there is the global error that tells me that the data was too long. So the point that I'm trying to make, and I hope I'm making it, is that the synchronization process is complicated, but we have taken all of the complication out of it and made it super, super easy. Yeah?
Quick question. Let's say I'm out on the field and I change a record.
Also gets in the recording.
Let's say that I'm out in the field and I change a record, and I get to my car and I have cell phone data access, and I hit the synchronize button. Does it tell me if somebody else changed that data while I had it checked out and was? So
yes, that's a write conflict. So basically, if someone else changed the data, when you hit the synchronize button, your synchronize will fail. And it'll fail because there was a write conflict, and it'll show you what the write conflict is.
I think you mentioned that. I was thinking, say they changed another field and it didn't generate a write conflict, but then if I'm looking at the data, did it inform me to say that data changed?
So what you're asking about is something, we've defined two kinds of synchronizations. We've defined something called sync push, and we've defined something called sync pull. So sync push is when you are pushing changes that you've made on your device back to the server, and sync pull is the opposite, is when you basically go back to the server to retrieve records that somebody else edited to update your list or your lists with the data with those changes. So there's an option in the list control to specify that you can choose to do sync pull and sync push independently or simultaneously. It's not necessarily a great idea to do sync pulls every time you do a sync push, because there's a much bigger payload involved in a sync pull than a sync push. But if that's what you want, that's what you get. So if you go back to design mode right now, and we go back to the list control over here, go back to list properties, and go now to our detail view, you'll see here there's a section here called Synchronization Policy. And the synchronization policy basically lets you specify that every time the user does a sync push, I also want to do a sync pull. And so if you do that, then when you do your synchronize, any edits made by somebody else will magically just show up in the list control for you to see. So does that answer your question? Great, okay.
Conflict resolution?
Yeah, okay. So what we've spoken about right now, up until now, is conflict resolution and how the user is involved in conflict resolution. But there's a lot more richness to the conflict resolution model in Alpha. So what I want to do now, in answer of Tim's question over here, is go back into the list properties here. And if I go now to table properties, we can see in this section over here. So first I should just sort of mention that the full Alpha security model is also available in the list with detailed views. So that means that you can authorize and authenticate people who have permission to do updates, inserts, and deletes. So you can attach security groups to all of these different permissions. But here in this section over here are the XBasic, soon to be XBasic or JavaScript, server-side event handlers that fire during the process of synchronizing data. So the first event is the before insert event. So that means that before a new record is inserted when you're synchronizing data, you have an XBasic event that fires, and you can do whatever you want in this event, like, for example, override values that a user might have submitted, add in missing values that you'd like to have. Like, for example, you might want to add today's date in a field called added on, etc. So before update obviously speaks for itself, before delete, etc., after insert, after update, after delete. So those are all of the events that you're probably already familiar with from using the grid component. So those same events are all there. But here's the interesting event, on-write conflict. So this is a server-side event that fires if there's a write conflict when the user tries to synchronize data. So what I'm going to do here is just go ahead here and click the button to bring up this little builder. And I'm going to specify the name of the function that I'd like to call. So I'll call it, say, xb write conflict. And then what I'm going to do is click this button here to show the function prototype. So this basically shows me the XBasic function that's going to get called if there's a write conflict. And it gives you the full documentation of what's going on, because this event is going to have passed into it the E object. And inside this E object is going to be data. It's going to be all information that tells me what the field was that had the conflict, what the original value was, what the current value on the server was, etc. And lets me specify whether I want to use mine, use theirs, or use some custom value that is neither theirs nor mine, but also mark it as resolved so that the user never gets to see the write conflict. In other words, the write conflict is going to be handled completely by developer code on the server and will never bubble up to the client. So I'm going to go here and just say copy to the clipboard, click OK. Let's just open up my XBasic functions, go there and paste it in. And then I'm going to go over here and put in a debug one so we can actually debug into this code. So I'll go ahead there and hit the save button, go there, and let's go there and save it. So now I'm going to go ahead now and run this. And actually, let me just get rid of that write conflict over there. So I'll go there. Actually, what I'll do before I run that, what I want to do is I'll point something out which is kind of interesting. Is when you're in design mode, it's very useful to kind of see what's in local storage right now. So right now, you know, every time I rerun this component, I'm bringing back everything from local storage. So I've got one of two choices. I can either go fix this error right now and then resubmit the data, or I can blow away local storage. So let's go back to design mode right now. I'll put my insertion point over there, go back to predefined controls here, and what I should see over here is somewhere, if I can just read here, is the local storage manager. So this is a predefined list control that shows me what's in local storage. So this is typically something that you would use in development mode, and it'll help you understand what's going on. So if I go there now and run this again, you can see that here's my list control and there's my menu, and I'm going to say show me all of the keys for this app. So here are the keys that are in local storage, and there are 3 different keys that are there right now. There's one called variables, which persists all of these variable values. There's one called info, and I can just click the show button to see more information about it. And here the biggest one at 3,000 bytes is the actual list data itself. So there's the list data that's being persisted in local storage. So I'm going to just go here to this menu here and say delete selected key right now. So I'm going to go and blow away that key in local storage. So So I'm going to delete that key. So now what's going to happen when I run this component now, can anyone anticipate what's going to happen when I run this? What am I going to see? Okay, so there I see nothing, but why am I seeing this over there? I didn't delete the variables key exactly. So let's go ahead here and do our search again, go get new data over there. And now what I'm going to do is I'm going to make an edit to this record over there for Eugene, make that say this is, let's go and find one near the top of the list. Let me go here and say, let's sort of sort that by, okay, so I'll just go there. I'll change this to Elgin, say a bunch of S's over there. So we've changed HUNGC. So let me go over to my SQL database now and go to Northwind customers. And the table that I was editing was, what was it again? I forgot. HUNGC, okay. So we'll go over here, find A, B, C, D, E, F, G, HUNGC. And what did I change? Which field did I change? I think they changed the city field. Okay, so let's scroll over here and change the city field here to, say, Boston. Okay, so now we're causing a write conflict now. So now I'm going to go back here and hit the synchronize button. And what I hope to see, and thank God I did, was that the XBasic debugger came up because the server-side on-write conflict event has fired now, giving me, the developer, the option for programmatically deciding how to resolve this conflict. So if I go here and just type in E into the debugger so we can examine what's going on over here inside this event handler, we can see that what we have available to us is the data. So we have all of the data. We have the old value and the new value, etc. And we can write in our XBasic code our own decision rules, and then we can set inside the code here basically whether this field has been resolved, is it resolved using mine or using theirs, etc. So this is how we can programmatically resolve write conflicts.
Is there any way to audit that?
Sorry?
Is there any way to audit that?
Absolutely. What you need to do is, this is your own XBasic code here. You can do anything that you want. So you can go here and you can write to an audit table basically what the values were, who submitted it, what time it was, etc.
You can email an administrator.
You can send an email. So basically you've got an amazing amount of control. And you can still bubble the write conflict up to the user, because this event fires if there was a write conflict. That doesn't mean that you have to actually resolve it yourself. You can bubble it up to the user and let the user resolve it as well.
Hey,
so,
Selwyn,
yeah,
are there encryption options for the cache data?
there are. So we haven't built in the encryption ourselves, but if you look at the event model here, and I'm going to have to, let's go back to design mode here, and I'm not sure whether, I can't remember whether we put them on the, let's go here and, so basically you can see there are events here, there are client-side events that fire before something is persisted to local storage and after something is retrieved from local storage. So these events are where you can add any type of encryption that you want to the data. So we didn't build the encryption in, but we put the events in so that you can add event hooks and encrypt the data and decrypt the data in local storage. So that's typically called, the industry term is data at rest. And so there are these encryption options for data at rest. Yeah, Dan?
Yeah, also, some of the wrappers that you might be able to get from the management systems will encrypt the data that is used by the whole browser. So that's one way. The other thing is that's the same place where you can persist other data if you want. If you have, besides the standard stuff, you have your own variables you want to persist, you can persist those too.
Right. So what we've tried to do as I've mentioned before, is create an event model that is very rich, so that even though out of the box you can sort of build a working disconnected application with, with the Genie in literally 15 seconds, that the event model is so rich that you can inject code pretty much wherever you feel there's a need to inject some code.
If I populate the list by doing a join, as you had indicated before,
Right.
where it says primary keys, and I would put in the primary key for each of those tables in the join.
Exactly.
And can I tried to follow your tutorial and used a view as opposed to the native tables. Am I able to use a view?
Yeah.
Okay, so I'll have to figure that out.
Right.
Thanks.
There's no basically, if the view is updatable, which is independent of alpha. Basically, it's, if you can do a SQL update statement against that view, say in Management Studio, then you can do the same thing in alpha.
But I thought a view with multiple tables, I can't. I thought a view that uses multiple tables is not updatable.
It depends on the SQL.
Oh.
It's got nothing to do with alpha. It's the database engine at that point.
Okay, thanks.
Right. Okay.
So not if it's calculated view.
Yeah.
So local storage, is that a property of a browser actually, or?
Yeah, local
Can you
storage is
make-
a property of a browser. So it's an HTML5 concept. All browsers have local storage. One of the things I spoke about on our roadmap yesterday was that currently we're using local storage for all persistence. But if you wrap in PhoneGap, and there's a limit to local storage, there's about a 5 megabyte limit to local storage. But if you wrap your app in PhoneGap, then through PhoneGap you can get access to the file system. So what we're going to be doing as part of our roadmap is using the file system instead of local storage for PhoneGap applications. And then, of course, you're going to have much more than 5 megabytes of local storage. One thing that I don't know if I'm going to have time to show here is in the UX Builder here, if you go to Properties, there's a section near the bottom called Local Storage. And when you're working in Working Preview, you can actually set local storage to the local file system. So instead of using the local storage in the browser, which you can't really see very easily, you can use the file system. And what's nice about that is when you're in debugging mode and you're trying to understand what's going on, you can just go to the file system and actually see a file on disk that contains everything that's been persisted to local storage. You can just look at it and you can actually sort of read it. So there was another question.
Can you filter the list to show only the rows that have been changed but not synchronized?
Yes, you can. We haven't actually built that in yet, but it would be trivial to do. But you as a user, basically, this is just a standard list control, so that the list control has a set
we'll
filter.
Show that. It's in the app that my app that I showed.
Okay.
It did
So-
that. You can just see, and that's part of the
Right.
stuff we're going to be giving you. I'll show that
But
this
basically, it's, the list control has a set filter method. The set filter method can execute any JavaScript function, so you just do a search for all of the rows where the underbar dirty property is set to true. And there are methods in the list that you can easily go and say, give me a count of the number of unsynchronized rows, unsynchronized updates, edits, and deletes. So that's all there. Yeah.
Yeah, if the user resets the phone or pulls the battery,
Yeah.
does the cache stay
Stays.
persistent?
That's the whole point. That's the whole point. So the cache stays there, and that's why this all works, because the local storage is persistent. Yeah. Yeah.
This is a great step forward. What is the plan to extend this local storage into other components? For an example, reporting off of local stored data.
Well, basically, so the question was, this is a great start, which we'd say thank you. But are we planning to extend it to things like, say, reporting against local storage? So the answer is that you can actually do that right now. And the reason that you can do that right now is that you can put anything that you want into local storage. The list data obviously is put into local storage automatically for you. The list data just represents JSON data. And the client-side templating library that we've got, that I showed very briefly yesterday, but where I showed how you took that JSON data that represented an invoice and actually produced, this beautiful formatted invoice using client-side templating, that would all work right now. So you could easily basically build a reporting solution that's working against local stored data using the client-side templating library that we've made. Yeah.
Selwyn, is the size of local storage dependent on the browser you're using or the device that it's running on?
I believe that it's sort of a little bit of both. I don't actually know the answer.
No, it's mainly which browser, the different browsers, but assume the limit is about 5 megabytes. You can test it to see also if there isn't, I think if it fails, it lets you know there's an error. I'm not sure.
No, there's an error. Basically, if actually what I didn't show, but I'll just sort of briefly go back here, is let's go back to that list control over here, and you recall that I spoke about the user needing to enter search criteria to bring data down into the list. So if we go now to the search part here, you can see that actually it's, let's go, I forget where I put it now. I think it's in list. Let's go to sort of events here. So list events, and there's search. Let's go here, type. So here's an event called on search result too large. So this basically means, now when you define on search result too large, you can define what too large means in two different ways. Too large, you can say too large is if more than, say, 10,000 rows are returned. That's one way of defining too large. But 10,000 rows is not really a great way of defining too large, because what if they 10,000 rows of one field each, right? That's not the same as 1,000 rows of 200 fields each. So another way of defining too large is the size of the payload in bytes. So, so those are two different ways of defining that a search was too large. But even if a search meets your criteria for size, when you bring the data back to the local device, you may still not have enough space in local storage to persist that data. So that becomes another error condition. The user has still, even though there wasn't too much data in their query, there's still too much data to fit into what's available in local storage. So you can see here there's a second event called on search result too large for local storage. So every time we write into local storage, if something goes wrong, there's an event that fires so that you can trap that and build that into your application. Yeah.
That 5 megabyte you mentioned, is that for the browser as a whole, meaning other applications?
It's for the domain.
Okay.
It's for the domain.
So it's just for the alpha app.
Now, but I want to stress a couple of things, that the 5 megabytes is a limit for HTML5 applications. Our goal, and what we certainly expect to deliver before the end of the year, is the ability with PhoneGap to use the file system. And so the 5 megabytes should not be I don't think you should consider the 5 megabytes a serious long-term limitation in your applications, because with PhoneGap that limitation goes away, and wrapping an app in PhoneGap is so trivial.
The thing is that if you're building a web-only app, one that isn't wrapped, you will have to think of it, but you'll find there are good reasons to use PhoneGap. But it's from the domain. So if you're using one domain for all of your apps and you have 100 apps somebody's using, they're only going to get the 5 megabytes for all those apps through that domain. However, that's why, as Selwyn showed in the manager, each app is stored with its own, has a different set of keys, so that you can go in there and you can actually figure out these are ones that are obsolete, I'm not using it. You can do all sorts of stuff, either programmatic. You can write a separate app to manage that if you want, etc. We give you the tools for that.
Yeah, so basically, as Dan mentioned, every UX component that you creates keys in local storage with a namespace that you define. So if you go back and you look in the in the UX, in the properties over here, let's go back to properties over here. You can see when we go down to local storage, there's something here called namespace. So this is the namespace that all of the keys in local storage that this UX component will use. So default means we'll choose the key, and it's going to be an ugly GUID. So it's a good idea to choose a namespace if you want. This is where you can specify whether you're going to use local storage or the local file system for working preview, etc. But knowing the namespace of your keys, and also you can give a friendly name and a description to the keys as well, and then using either using the manager that we showed you where you can manage local storage, or using the methods that are documented. There are hundreds of methods that are available for the list that are all well documented, and a quick access, you can get very quick access to the documentation and the version as well. You can get quick access to all of the documentation just by just going over here and clicking that. Okay, I don't have an internet connection at all right now, so that's too bad. But anyway, so there's the documentation, and there are a ton of built-in methods for managing local storage. So I've got 5 minutes left right now. So what I want to do is quickly show how I can take this app right now, and obviously so this app right now, it's a working disconnected application right now, but it doesn't look yet like a mobile application. So what we want to do is I want to just very briefly go and show, there's two things I want to show in 5 minutes, which is kind of too bad. But so here is that same application now, and you can see now I've taken that application, and now all of a sudden it's looking a little bit different over here. So it's been styled now as a mobile application. So there's my list control. When I tap on that row, I get my detail view. When I go back there, etc. So we're going to take this app and just very quickly start to go through the process of styling it. But the other thing that I wanted to mention is that we deal very well with hierarchical data as well. And that's the real world, is that you don't just have a list of customers. You have a list of customers and transactions. You have orders and order details. You have basically you have one-to-many relationships all over the place. That's all apps have one-to-many relationships. And so when you go offline, you need to bring, say, your customers down, but you also need to bring the orders that those customers have placed. And then you need to bring down the line items that those orders for those customers have placed. So what you're really talking about is a hierarchical set of data that you want to bring offline. So if we look here at this component over here, we see something very similar. We start out with a list of customers over there, and then we have another list underneath that of a list of orders. And if we go into the list properties here, what we see is that this list we've specified that this list has a parent, and that its parent is the customer list, and it's linked on those common customer ID fields. And most importantly, we'd like to prefetch the data for that list. That means that when I do my initial query in the morning, before I go offline, I'd like to fetch not only the customers, but also all of the orders for each customer that I fetched. And then basically going down the hierarchy one more level, I can go now to my order details list over here, go over to the definition, and again I can see that this list has been marked as having a parent over here. So now we go ahead, and what I'm going to do is, first of all, well, let's just go ahead and run this now. So you can see now that basically there's no data there at all because we haven't done our search yet. And I'm going to go there and type in USA, and now go ahead and do search. So what happened now was we did our callback to the server, and we fetched all of the records for all the customers in the United States. And then we basically fetched all of the orders for all of the records that were in our customer list. So if I scroll down now, I can see over here are all of the orders for the customer that currently has focus. So if I go there and click on that customer there, there are all of the orders for that customer. You can see HUNGC, that's the customer ID. So there's LAZY, and there we go. There's LAZY over there. And then if I click on that data over there, you can see now that there are the line items for that customer. But the important point is that when I navigate these lists here, there are no AJAX callbacks taking place. If I go and look at this in Firefox, for example, and look at over here in Firefox, let's go here and type in, say, USA, and then go hit search and populate the data. And then I'm going to turn on Firebug here. Actually, let's do this, and I'll type in, say, France. And then go ahead and hit the search button. So let's just scroll down here. What I'm doing here is I'd like to show you the payload that gets sent from the server back to the client. So you can see here's the payload. There is the JSON data that represents the customer. So there's the customer. Then embedded in that customer record are the orders. And then embedded in that are the order details. So there's all the data coming back from the server. So we did, on the server side, we did a SQL query against the customer table, and then we did another SQL query against the order table, and then against the order detail table. We took all that data and created a JSON package. So even though this looks like the kind of result that you would normally get from a NoSQL database, we actually got this from a SQL database. So we basically have taken a SQL query and returned a complex JSON document that represents hierarchical data over there. And now what you can do is you can see, if I go there and clear this, we can watch AJAX callbacks taking place. You can see now that as I go from one row to the next row to the next row, there are no AJAX call taking place because all of the hierarchical data is already sitting there on the device. Now what's interesting about this is that synchronization and data entry all happens automatically. So if I were to go, for example, to this order detail record and mark it now as well, not mark it, but actually make an edit. So go ahead there and hit save. You can see now that this is now dirty over there. But if I scroll up to the orders table, which is the parent of this table, you can see here that this is marked and it looks like a light orange as opposed to a dark orange. So the reason that this is marked here as light orange is that this row itself has not been edited. But it's, in effect, it's dirty by implication. It's dirty by inheritance. Its child is dirty. So, and then if we go up one level here, that didn't quite come out right, did it? Okay. All right. So, and the parent, yeah, this is the grandparent row. This is also dirty by implication, right? So now if I go here and do a synchronize, it doesn't matter at what level I synchronize because we're going to synchronize the composite row. Go ahead and hit the synchronize button, and now you can see the dirty mark there has gone away. The dirty mark there has gone away. The whole thing has been synchronized. So we've synchronized the complex hierarchical data as seamlessly as if we were synchronizing a single table. And what Alpha has done is taken that complex object that got sent back to the server of the JSON that represents the changes to the parent record, the child record, the great-grandchild record. We've decomposed that into a bunch of changes and computed SQL update statements against each of the individual tables. And had anything gone wrong in that process, the whole thing is wrapped in a transaction. So if anything had gone wrong, as we were doing that update, the whole thing would have been unwound and the error would have been reported to the user. Yeah.
Selwyn, can you maybe comment for the audience? I'm curious whether people have dealt with this offline issue with other products and sort of understand the complexity involved.
Tim would like to say something.
Well, so I've been working with mobile data for about 12 years, and I've spent a lot of money. In one case, $70,000 for a synchronization server.
That's what our product costs, Tim.
Well, in recent years, what I've done is actually written my own, and I can tell you it takes, well, the latest incarnation, hundreds of ETLs to, essentially replicate data, and we do it in a very big way. And I can't say enough, what a wonderful job they've done with this and how they've abstracted all of that complexity from us or for us, so that now we can just focus on really moving data to and from. So to be able to just drag and drop, make a few a few changes, maybe load some methods, and the conflict resolution itself is just amazing. So anyway, I just want to say thank you very much. It's you made a very complex problem very easy.
There's one over here.
Just a quick clarification. The data that you send back from the server, is that stored in local storage in that JSON format?
The answer is yes. So basically, every time you do a query against the server to retrieve a new set of records, those records are persisted in local storage. And so that means that you can, for example, in this example over here, I go and I type in, say, search USA. I go get all customers in the United States. I get all their customer records. I get all the order records. I get all the order detail records. As soon as I've done that query, I could turn my phone off. I could exit the application. I could turn my phone back on. I could re-enter the application, and all of those records that I had just retrieved from the server would be there.
Was there anybody else who had experience? Any other person who wants to answer Richard's question?
Yeah, it's not really about the synchronization, but it's a question related to what you did.
Okay.
Yeah, it's difficult. But I would just say that I have extensive experience actually writing these synchronization programs, and it's horrible. Using a local database, trying to synchronize it, so it's still a good job, Selwyn, and I anticipate it very much. But the question is, now you brought down all the orders, etc., etc. What if I want to create a new record, a new order, and I would need some new products? How would I get the products in the morning? All the products, I don't want the user to select them.
Okay. So first of all, creating new records is an interesting problem because when you create a new, say, let's say you create a new order, so the order is being created for a customer, and when you create new line items for a new order that was just created, those order items are being created for a new order. But when you synchronize that, basically, you've got to think about, well, first of all, you've got to make sure that we already know that this new order was created for a customer. So because the data is all hierarchical, we know what the linking key fields are. So we know that we need to put the customer ID from the parent record into this new order record automatically, so that's going to be done. We also know that basically the new order that you create might have, the order number might be an order increment field. So you're not going to know what that order, what the new order ID is on that order until you've committed that record. And then once you've committed that record, then you need to know that when you start creating the order items for this new order, for this new customer, the primary keys, the linking keys have to all automatically be taken care of, put in, so that the records are all linked automatically. So that basically is all taken care of automatically. Now, with regard to products, for example, so products is actually a good example of a use case that where the list of products that you have is typically something that doesn't change very often. So you could actually put the product information in a static JSON file that's linked into your application. But then every once in a while you want to press a button that goes back to the server, maybe to get new products that have been added to the product database, remove products that have been removed from the product database. And this data can be dealt with differently than say the customer order details, because that's not information that you're going to edit on your mobile device. That is more what we call lookup information, and lookup information is very nicely handled in the list control as well. So are you giving me dirty looks right now? Is it time for me to stop? Okay. So I'm going to have to stop right now because my boss is telling me that. But what I haven't covered, and what I would like to maybe find some time to cover at some point in time, is how we take what I showed you right now, which was all generated by the Genie, and turn that into something that looks like a mobile application. And then what I'd like to do, I'll show you how we do that. But what's really important about what I'm going to show there is that what that is generating is an app that looked like the one that I showed. But then what we're going to do is take that to the next level and then show where we're heading with these touch forms and how this afternoon, okay, and then how Genies will generate touch forms. So you're going to go from nothing to a full mobile application doing CRUD operation against multiple tables, all without writing a single line of code, basically. So that's our goal, and that's what. So unfortunately, I didn't get to show that this morning, but I guess we'll have another chance. So thank you very much. I appreciate your time.